Good afternoon or evening or morning to my favorite geometry students. Today we're going to be talking about 9b, the Pythagorean 9.2b, the Pythagorean inequalities theorem. This is really a continuation of the Pythagorean theorem and its converse. It was just going to be too long to put into one video. So make sure that you take the time to come down here, update your table of contents so that you have your composition notebook ready to turn in at the end of the chapter. Our today's objective is to use the Pythagorean inequalities theorem to determine if a triangle is acute, right, or obtuse. All right, so let's talk about the Pythagorean inequalities theorem. So when I think of this, this is always going to be my longest side squared, and I always put it on the left. If this triangle is right, that would be my hypotenuse. So if the longest side squared, c squared, is less than a squared plus b squared, then what happens is triangle ABC is going to be acute. So if I come over here and I make this triangle ABC, all of the angles in that particular triangle are going to be acute. Now, what happens if the flip happens? What happens if we change the inequality from a less than sign to a greater than sign? And this is going to be my longest side squared. There's always going to be that c squared. It's greater than a squared plus b squared. Then the triangle ABC happens to be obtuse. So if you look at the picture, angle B is obtuse, which makes that an obtuse triangle. The key to this is always making sure you isolate that longest side. And for me, I put it on the left-hand side because then if it's smaller, when I think of the word smaller, that is associated with the word acute. And when I think c squared is larger, larger is easier for me to associate with the word obtuse. All right, so determine if the triangle is acute, right, or obtuse. So looking at this triangle, I got to decide, is 15 my longest side or is square root of 190 my longest side? The square root of 196 is 14. It's actually equal to 14. So 14 is less than 15. So this right here is going to be my longest side. So I'm going to isolate that over here on the left. And then I'm going to have to determine, is this greater than, less than, or equal to 6 squared plus the square root of 190 squared. So doing a little math, and if you've learned those perfect squares, this is so much easier. I really don't want you to get out your calculator. The square root of 190 squared, remember those are inverse operations and they cancel each other out, leaving you with 190. So if I think of 225 and I take 36 plus 190, this is going to be 226. 225 is less than 226. So remember, this was your longest side squared, and it is less than 226, and that's going to make this triangle acute. All right, I want you to look at example B. I want you to take a minute, hit pause, and see if you can work this one out on your own. When you are finished, please hit play and resume. All right, welcome back. I look at this triangle, 17 is my longest side, so I have 17 squared, and then I have to determine, is that greater than, less than, or equal to the sum of the other two sides squared, which is going to be 11 squared. 5 square root of 3, I need to put a grouping symbol around that to make that mathematically appropriate, and yes, that is important because this square not only goes to the square root of 3, but it also goes to that 5. So 17 squared, 289. Is that going to be less than, greater than, or equal to 121? 5 squared is 25. The square root of 3 squared is 3, which this is 75. So now I have 289, 121 plus 75, 85, 95 is going to be 196. So when I look at this problem, 289 is greater than that. So my longest side squared is greater. And for me in my head, I think greater or bigger is associated with the word obtuse. And that makes this triangle, I don't even know what word I just wrote. That makes this triangle obtuse. See if I can spell it correctly. There you go. All right. So example number 6. The size and classifications of a triangle is given. the length of the longest side is the integer given. So they're basically telling you that this is going to be the longest side. What values of x would make the triangle? So I know that 14 squared is going to have to be greater than the sum of the two shorter sides squared. So now if I do 14 squared, this is why it's important you have your perfect squares memorized through 20. X squared plus x squared is 2x squared. Divide this by 2. And 196 divided by 2, if I remember correctly, is 98, is going to be greater than x squared. If you come in and we take the square root of both sides, we have the square root of 98 is greater than x. So now I'm just going to come out here to this side and take the square root of 98. The only thing I know about 98, it's even, and 98 times divided by 2 is 49, which actually works out quite beautifully for us because I cannot take the square root of 2, but the square root of 49 is 7. So 7 square root of 2 is going to be greater than x. All right, the biggest key to these problems, I'm going to tell you, is when you set this up, always put the longest side squared on the left, because then words like obtuse and acute make sense in the context of the problem. If you do that opposite and put that number on the right, it's fine, but then you should read it from the right-hand side. So you know me, I'm all about like consistency and patterns and things that will help me remember and not make it confusing when I teach a bunch of you at once. So if I had to give you one tip for that lesson, that would be my tip. All right, I know this is your favorite, coordinate geometry. You will thank me on the ACT. Connect the points to form triangle ABC. Decide whether the triangle is acute, right, or obtuse. So let's plot said points. So just y'all take a minute, hit pause and do that. -2, 2, 4, 6, 8. Yes, you know, I talk to myself. For me, I like to label the points on my graph because then I don't have to keep looking at the problem statement, because for me, I get confused easy. So this is 3, -4. And C, 2, 4, 6, 8, 9, +1. C is 9, 1. Okay, so the beautiful thing about this is if I draw this triangle, even though you want to make assumptions, you cannot really make assumptions about this triangle. Like, I'd like to assume that it's acute, but when I look at my line AB, that is far from a straight line, so definitely not going to make any judgment calls. Now, here's what you're going to have to do. You're going to have to find the length of each side. So what you have to be thinking about in your head, and we've been doing these problems for a while, if you want length, do you need to find the midpoint? Do you need to find the distance? Do you need to find the slope? So in your head, you should be processing and making that decision. So when we find length, we're going to use the distance formula. Unfortunately for you, that means that you're going to have to come over here and you're going to have to find the length of side AB, and then you're going to have to do it again for AC, and you're going to have to do it again for CA. So looking at this problem, hit pause, and you guys just take a minute to find the distance. I'm going to do this very quickly, so you hit pause and then rejoin us. And like I said, I'm going to work through this really quick. So square root of 25 plus 44, 144, 44, 54, 64 is 169. And the square root of 169 happens to be 13. So that's beautiful. Okay, so now the length of BC is going to be the square root. And if I subtract those, I get 6. And 6 squared is 36. If I subtract those, I get 5. So we end up with the square root of 36. And again, if you're trying to do the work with me, stop, hit pause, and take your own time to do this. It can be confusing, and I am going super fast and skipping steps. Okay, so 9 minus -2 is 11. 11 squared is 121. 1 minus 8 is -7, and 7 squared is 49. So 121 and 49. So 121, 130, 30 plus 40, 70 is square root of 170. Okay, so now I have to determine. So now Hopefully you've rejoined me now. So now, in order to determine if the triangle is acute, right, or obtuse, then I'm going to need, first of all, to figure out which side's the longest side. So when I look at this, I have 169, 61, and 170. So 170 barely is the longest side, assuming I've done all my math correctly. So if I take the longest side, I'm going to take the square root of 170 squared, and I am going to have to make the big decision. Let me pick another color for today. Greater than, less than, or equal to. Is that greater than, less than, or equal to the square root of 61 plus 61 squared plus, and I'm just going to leave this as square root of 169 squared. It makes it a little easier. All right, so over here you get 170. Here you get 61 plus 169, and without even doing any more math, I know that 170 is greater than 169, so that's all I need to know for this problem. And because this side, the longest side squared, is greater than the sum of the other two sides squared, that tells me that this triangle here is obtuse. Barely. I mean, it's barely obtuse. All right. Hopefully you understand. There is one more example here. I do not think this example is in your notes, so I'm not going to do it. If it is in your notes, go ahead and do it, and we will visit about it another day. Have a great day. I'll see you tomorrow.